We're going to continue our series on Back to Basics, and today we're going to be discussing routing of ductwork and some methods to get your ductwork in your model quicker and easier. So routing ductwork, I just have a couple suggestions before we actually get into AutoCAD MEP and showing the routing of ductwork. And these are my suggestions. They work for me. Hopefully they can work for you if you use them. I prefer to split my screen into a plan view and an isometric view into two different viewports. That way I can see what is happening in plan view where I do most of my drawing, but right on the other side of plan view. I can also see it in 3D view immediately, and this has some advantages of being able to change your elevation by grabbing and stretching the grips on your duct, which we spoke about in previous webinars a couple meetings ago. So I like to keep my screen split, but I certainly don't like to shade my viewports. I see a lot of people that shade them either in a conceptual view or a realistic view, and if you have a really powerful computer, then by all means go ahead and do it. But the shading really just takes away from your computer processing power and slows things down. You can certainly see everything that you see in a shaded view in the standard 2D wireframe view. You just need to get used to it and train your brain to see the same things. Your brain's very powerful, and you can certainly train it to see the same thing that you see in a shaded view in a wireframe view. I have written down here command line, command line, command line. Because I see a lot of people routing ductwork with their mouse and they use the property palette and they never look at the command line. And there are some very specific options that are available on the command line while routing that we'll get into. The important ones being the ability to change the plane that you are routing on, and we'll get into that. And enabled to do that, you need to have your compass enabled. You can change the size of your duct as you're routing using the command line, and you can change the slope, all of which are available on the property palette. You can generally get to them a lot quicker and easier by using your keyboard in the command line. When routing duct, I prefer to use my routing preferences as much as possible to get my parts into my model or my drawing and then manipulate them afterwards. Once it's in your drawing space, it's a lot easier to manipulate than trying to go into your part catalog, scroll down, find the part, bring it into the drawing, then manipulate it, rotate it correctly. It's certainly all doable, but it takes time. Use your routing preferences as much as you can to get the part where you need it to be, and then manipulate it using the properties palette or the command line. And then parts that aren't available with the routing preference, put them on a tool palette, and we'll quickly go over that, how to get your parts on a tool palette so you don't have to go through your parts catalog to try to find them. So let's skip over here into AutoCAD MEP. And let's get some duct in our drawing. And you'll see that I have my screen split. On my left-hand side, I have it in plan view or top view. And my right-hand side, I have it in an isometric view. And both of my screens are set up in wireframe. And before we get started, most of you know, but in case you don't, if you go into your options on the EC Tools tab, I have my duct brake set up to brake automatically based on the length set in your specifications, and I have auto tagging turned on, and this will once the duct is into your drawing, it'll go ahead and put your tags on based on your auto tag setup. And we'll get into auto tagging in our next session, so I don't want to go over it too much today. So let's get some duct in our drawing. So I'm going to start with the 36 by 36. I'm just going to start here on the left-hand side. I said, command line, command line, command line. One of the things I want to make sure that everybody has turned on is their compass. You can see that I just turned that off. Now I turned it back on. What your compass allows you to do is, see the angles and give you notches or divisions to get your angles when you're routing ductwork. Very powerful. But more importantly, when you're over here in a 3D view, it shows you the plane that you're currently drawing on. So currently I'm drawing in my top plane. So if you look at the orientation of that compass versus the orientation of my view cube, you can see that I'm in the top plane. So when I go to turn my duct and put a piece in there, an elbow, it's always going to rotate that elbow in the top plane. But if I come down here again and I look at next to the compass, there is a command called plane, or if I just hit the P key for plane, you can see that my compass changes its plane. I'm now drawing in the front view, and when I go to route an elbow, it'll actually rotate that elbow up or down or sideways in the front plane. So this allows me to be drawing in the top plane, then all of a sudden turn up or turn down into a riser. Now if I hit the P key one last time, it'll turn to the left plane, and that just allows me to draw and turn in that plane also. So 3 very valuable tools there with the plane command that allow you to continue routing your ductwork without actually stopping and placing a fitting and rotating it. You're using your command line to do everything. Sorry, I'm getting a little bit of slowdown there on my system. So what happened was I drew a lot of duct without stopping, and then when I was done, it's going through and it's breaking up all the ductwork, putting in all the tagging. In a normal day-to-day environment, you won't be using the tools like that. So the command line, compass, and plane, again, extremely powerful. Some of these other tools allow you to change your routing preference as you're drawing, change your size. So lots of times as I'm drawing and I need to all of a sudden change down to a smaller duct, instead of going to the routing preference, I just type SI for size, then maybe change the width to 30, choose W for width, change it to 30, and then go on. And so you see that it put in the transition right away to go to my 30 inches. So the point of all of this is to really pay attention to the command line and the options that are here. If I start that duct command one more time, one of the tools that I use the most off the command line is the elevation command, which you see right down here towards the middle. So when I'm drawing duct, I know at what elevation I'm drawing at, and if I want to go up to another elevation, I just type in EL for elevation, and then I'll put in the elevation that I want to go to, in that case 12 feet. To really make that effective, you need to make use of your justification tools on the property palette. And they're also available on the command line. It's just in this case I prefer to use the justification over on the property palette because it is visible versus the text tools on the command line. So most of the time you're going to be routing ductwork based on the bottom of duct elevation. So I set my justification to bottom center. Then if I come in here and I say 12 feet as my elevation, then when I start routing duct, it's going to put the bottom of duct at 12 feet. And you can see right there from my tag that that's true. That will allow me to, then when I use my elevation command, now let's say I want to go up to 15 feet. it's going to put in the second piece of ductwork at 15 feet. And let's see, I had something set there that I shouldn't have. Gave me a little bit of trouble there. DL 15 feet. And see, what's happening now is I'm not going up high enough based on my duct, and so it's getting a little bit confused based on the height of my duct, going from 12 feet to 15 feet. It's not enough to really do what I'm telling it to do, so it's getting a little bit confused. So in reality, you would not go from 12 to 15 with an elbow. What you would probably do is put a different type of fitting in there. And we will get to that on how to do that in just a quick second. What I want to do now is just go back and look at a couple specialty tools that are available when routing duct to get your duct placed correctly. And one of the things that we get a lot of calls on how to work, and it's a little difficult to understand until you find the tool to be able to do it, is how to adjust your taps when routing duct. There's two ways to place a tap. One is to manually place them, and to do that you go and you grab your tap from your catalog and you come in and you place it on your duct. The other way is to grab the plus grip from the center of the duct and pull the tap out of the ductwork. Both of them work fine. There's just one very important difference between the two, and that is when AutoCAD MEP automatically pulls a tap using the plus grip, for whatever reason it does not place the correct anchor between the two. It places an anchor that does not allow you to move the tap up and down on the fitting. So you need to update that anchor to the correct type. And just to show you how easy that is, if I check this plus grip and I go and let's pull a 20 by 20 duct out of here, you can see that it placed the tap where it needs to go. And if we look at that in 3D, we can see that it placed it on the bottom of the duct. That's because my justification was set to bottom center. If I select that, you can see down here on the property palette it has a takeoff position, and it allows you to adjust the position of the ductwork. Now if you notice what I said earlier, I said that when you pull with the plus grip that it doesn't place the correct anchor on there. And there, I just needed to clarify that just a little bit. When you have a center justification and you automatically pull the tap out of there, and here you can see it was placed in the center of the duct. When I select that and I come down here again to the property palette, you can see now that there's something different there. It says anchor. And when I select that, it gives us a totally different dialog. That is because when you have your justification set to center, AutoCAD MEP does not put the correct anchor on the tap. To get around that, EastCoast has placed a tool up here on your ribbon called Tap Anchor Update. When you select that, that'll change the anchor to the correct anchor for a tap, and then when you come over to the property palette, again you'll see a takeoff position under Advanced, and you can select that, and that will then allow you to start manipulating the placement of that tap on that piece of duct. By default, the tap is always set from the center of the duct. For us, that's not going to work. It makes it very difficult to move that tap around. So what we need to do is first determine what side the tap is on. We routed our ductwork from left to right, so our tap is on the right side of the duct. So if I come here and say my side is on the right, and if I just hit OK, you can see that it just flipped that tap around real quick. I can go ahead and tap it back, hitting my flip arrow here if I want to get it back on the correct orientation. If I come back to my takeoff position, you can see that I'm still on the right, which is where I need to be, But now I can justify that tap to either the top of the duct or the bottom of the duct. In this case, I'm going to go ahead and go to the top, and let's say I want to hold that down 2 inches from the top. Now the way this offset works, it doesn't work as you think it would be, that 2 inches means it moves the tap up 2 inches, and -2 means it moves the tap down 2 inches. What it is, it's 2 inches away from the justification. So if I have this set to top and I have my offset at 2, then it's going to move it down from the top 2 inches. If I have this set to bottom and I have my offset set to 2, then it's going to move the tap up 2 inches. So if we set this to top and hit OK, we can see that our tap came in here. And if I just real quick do a distance command, see if I can do this in 3D, come up, you can see that it is exactly 2 inches. You will need to take your duct here, so I select my duct, choose this triangle, and just pull it up to that connector point right there. And that'll bring everything back into play where it needs to be. So once you understand the tap anchors, and to make sure you get the correct anchor, using this takeoff position dialog, it's very simple to get your duct positioned where you need it to be. So if I need to move that 4 inches from the top, I just change that to 4 and hit OK. You can see that my tap moved down. If I need to change the position of that tap, if I need it to be on the top of the duct, then I can just come over here and on my side set at the top and hit OK. And we can see that that tap moved right up to the top of the duct. So once you understand the tap, the anchoring, and where to grab this position dialog, getting that tap to move to the correct position is very easy. The most important thing to think about, though, is the order, the direction that you drew the main trunk of the duct. Direction is always from connection 1 to connection 2. And just to prove that real quick, I'm going to go ahead and draw another piece of duct in here. And I'm going to pull a tap off of this. Let's change to a smaller size, 16 by 16. Let's go ahead and pull it this way. My justification was set to center, so I need to update my anchor. And let's pull some of these tags off of here. Easier to read. So if I select this, I go down to my takeoff position, and I do like I did on the previous one. I changed the side to right, because looking at it from left to right, it's on the right side, and I hit OK. You can see that it flipped to the other side of the duct. It's not on the same side as this duct. And both of those are set to the right side. We come down and verify this one again. You can see that it's set to the right side. So as I mentioned, this is connector 1, this is connector 2. So you look at the duct from right to left, and that tap is actually on the right side. It's just because the orientation of the duct it's attached to is rotated. So that makes a very big difference when routing duct on how the taps are. Now, one of the things that we also mentioned on the previous slide was, throwing your fittings onto a tool pallet for easy retrieval. So we have this shoe tap in our drawing, and I'm going to go ahead and first thing I need to do is save my drawing. So I'm going to throw it on my desktop and just save it as drawing 1, because you can't create a tool palette without having your drawing saved. And let me go ahead and make sure I'm in the right group, and let me go ahead and create a new palette. I'm just going to call this East Coast. So once I have a palette over here, I can grab this tool, left click with my mouse, hold the mouse button down so I get the rectangle by my cursor. Then I can bring this over to my tool palette and drag and drop it in. And that will allow me then to come over here whenever I need it, to select that tap and place it into my drawing wherever I want. So now I can come over here and place it on this side, and it's right there. I can come over here and place it over here, and it's there. So just real quick and easily, I'm going through and I'm placing taps on these fittings. If we look at each one of those, we can see that it automatically has the correct anchor on it right away because we get the takeoff position dialog. So manually placing your tap gives the correct anchor every single time, even when it's in the center of the duct. So some good tools to learn and understand. Make sure that you place your not so common fittings onto your tool palette for easy retrieval. Make good use of the anchor dialog. All of that will save you a lot of time.